Hello everybody. We're going to take a look at finding least common multiples using prime factorization. This is section 2.4c of unit 4, and these are the two problems we're going to look at. Find the least common multiples of 6, 9, and 15, and the least common multiples of 10, 18, and 30. Let me get my tablet and we'll take a look. 6, 9, and 15, and 10, 18, and 30. All right, so for these we're going to use prime factorization. So prime numbers again, the lowest ones, 2, 3, 5, 7, 11, and 13, and probably you will use just the first 5 mostly. So let's break those down using a factor tree. 6 can be broken down into 2 and 3. 9 can be broken down into 3 and 3, 15 into 3, and 5. And for this, it sometimes helps to write the numbers. We've got 2 and 3, 3 squared, and 3 and 5. So to choose the numbers, we have to get factors that are shared by all. And because these are factors made using prime numbers, if you have the same prime used more than once, we need to get the ones that use them the most. So imagine yourself at a buffet, and you have to try some of everything, but you're going to take the dishes that have the most in them, okay? So it's a little bit greedy, but it will get you the right answer every time. So on this buffet, we have a 2 and a 3 at this table, and we have 3s at this table, but look, there's a double stack. And then 3s and 5s at this table. So we're going to go, we're going to get the 2 from this table because we want that. And then we're going to grab the 3 from the middle table because this is doubled, right? 3 times 3. It's going to be a nice big helping. Hope we enjoy it. And then over here we got a 5. So with all of these, multiply all of these together, we will get the smallest number that all 3 of these can divide into evenly. So 2 times 3 squared times 5. So if we use PEMDAS, that becomes 2 times 9 times 5. And still sticking with PEMDAS, 18 times 5 and the magic rule of multiplication by 5. Take half of 18 and add a 0, 90. 90 is the smallest number we can use for 6, 9, and 15. These all divide into 90 evenly. So that's how we find it. Okay, let's take a look at 10, 18, and 30. 10 breaks down into 2 and 5. 18, 2 and 9, which breaks down into 3 and 3. 30 breaks down into 3 and 10 and 2 and 5. So you can break these down any way you like. You could start with 2 here and get 15 and then go to 3 and 5. You will always get the same prime numbers as the factor of that one. I've said this before. They're like a special zip code that only points to that number. So let's write these with exponents. So here we have 2 and 5, 2 and 3 squared, and here we have 2 and 3 and 5. And remember, we're thinking about the buffet. And we have to try some of everything, but we're going to take the biggest dishes we can to make everyone at our table try some too. So we're going to have to try 2s and 3s and 5s. So if we take these two, and the 3 squared will be good. We can ignore this table because we got our 2s and 5s over here. So the number is going to be 2 times 5 times 3 squared. 2 times 5 is 10. 3 squared is 9. 9 times 10 is 90. So it looks like the same number that worked for 6, 9, and 15 will work for 10, 18, and 30. So 10 goes into 90 9 times, 18 goes into 90 5 times, 30 goes into 90 3 times. And up here, 6 goes into 90 15 times, 9 goes into 90 10 times, and 15 goes into 96 times. So this is a foolproof method, and almost foolproof, I guess. Works really well when you are dealing with more than 2 numbers or when you have big numbers that you just don't want to have to deal with. Break them down into their prime factorizations and be greedy at the buffet. You're going to try some of everything and take the biggest dishes of each type there is to grab. All right, give this a try and see how it goes. If you get stuck, message me.